All right, this is a question on variation of parameters because we have a linear second order differential equation with constant coefficients, but non-homogeneous because we have a right-hand side. So the first step is to solve the corresponding homogeneous differential equation. To do that, we first need to write down the characteristic equation. So the characteristic equation is r squared plus 3r plus 2 is 0. Well, and I think you can it is fairly easy to guess that the roots are, well, the product of the roots is 2 and the sum is -3. So you can guess that the roots are -1 and -2. Yeah, so it means that the general solution of the homogeneous equation is going to be some constant c1 times e to the minus t plus some constant c2 times e to the minus 2t. All right, so now this e to the minus t is going to be y1, and this e to the minus 2t is going to be y2. The second, now we have solved the homogeneous equation. Now to find the particular solution of the non-homogeneous equation, we need to apply variation of parameters. To do that, we first need to write the Wronskian. So the Wronskian of y1 and y2 is the determinant of the matrix where the first row is y1 and y2. And the second row is their derivative, so minus e to the minus t and minus 2 e to the minus 2t. Now, this times this is minus 2 times e to the minus 3t, minus this times this, so we have minus and minus plus e to the minus 3t, so we get minus e to the minus 3t. Right, so the Wronskian of the two solutions is minus e to the minus 3t. Okay, so now we're going to look for a particular solution in the form y1 times u1 times y1 plus u2 times y2, where u1 is the integral of y2g over the Wronskian, which is the integral of y2 is e to the minus 2t times g. So in order to, so g is the right hand side, but we need to make sure that the coefficient at y double prime should be 1. So, and here it is indeed 1, so we don't need to do anything. So g is just the right hand side, is 1 over e to the t plus 1 divided by, our Wronskian is minus e to the minus 3t dt. This is what? Is minus the integral of, oh, sorry, I forgot to the minus sign here, right? That there should be the minus sign here, minus sign here. So there is no minus sign here, and it is just e to the t dt over e to the t plus 1. Now e to the t dt is d of e to the t, so the answer is ln of e to the t plus 1. Okay, so this is u1. Now u2. u2 is going to be the integral of y1 times g over the Wronskian dt, which is the integral of y1 is e to the minus t. G is still 1 over e to the t plus 1. Everything divided by the Wronskian, which is minus e to the minus 3t. Now this is minus the integral of e to the minus, sorry, e to the minus t divided by e to the minus 3t. So this is going to be e to the minus t plus 3t. So this is e to the 2t dt divided by e to the t plus 1. Okay, so how do we do this? This is a bit more complicated, but I hope it's not too bad. So we need to do a u substitution. So, well, as a matter of fact, I did a u substitution in the previous integral, only I kind of did it in my head, so I did not write it down explicitly. So u equals e to the t, so du is e to the t dt. This whole thing is, so e to the 2t is e to the t times e to the t dt. So one e to the t dt becomes du, and one more is just u. So this is u du over u plus 1. All right, great. Now, how do we do, and of course, there should be the minus sign here. How do we do this? So this is still minus. To do this, we need to do a simple trick. So add plus 1 minus 1 here, divided by u plus 1 du. This is minus. U plus 1 over u plus 1 is 1. So this is 1 minus 1 over u plus 1 du. So this is minus u plus logarithm of u plus 1. Strictly speaking, absolute value, but u is positive, and so is u plus 1. So this is minus e to the t plus ln of e to the t plus 1. So this is our u2. Okay, so finally we just need to substitute it. Now y is going to be, what is going to be u1 y1 plus u2 y2. This is the particular solution plus c1 y1 plus c2 y2. This is the general solution of the homogeneous equation. Okay, now u1 is our y1 is e to the minus t, right? Yes, our y1 is e to the minus t. So times u1 is ln of e to the t plus 1, right? So this is y1, this is u1, plus e to the minus 2t, so this is y2, times minus e to the t plus ln of e to the t plus 1. This is u2. Now plus c1 e to the minus t plus c2 e to the minus 2t. Okay, how can we simplify this? Well, I have e to the minus t ln. Okay, so maybe let me group them together. So we have this term, this term, so we can group them together. So we are going to get e to the minus t plus e to the minus 2t times ln e to the t plus 1 plus e to the minus 2t times minus e to the minus t. So this is minus e to the minus 2t plus t is just minus t. So this is really e to the minus t plus c1 e to the minus t plus c2 e to the minus 2t. Okay, but notice that we have e to the minus t here, e to the minus t here, and if we group them together, we're going to get c1 minus 1 times e to the minus t. But if c1 is an arbitrary real number, then c1 minus 1 is also an arbitrary real number. And since we are doing the general solution, we don't really need this term at all. It is accounted for in c1 times e to the minus t. And this is the final answer.